Advanced Algebra 1.2, we're going to be looking at using the point-slope form. This form we can use instead of using the slope-intercept form. We could solve all the same problems with either one of these forms. We do need a point and a slope for this, hence the name of it, but if we were using our slope-intercept form, we'd also need a point and a slope. So we're kind of at a similar point. So where this even is derived from is if we remember our slope formula. So our y2 minus y1 over x2 minus x1 equals our slope. Now I separated that for a reason. If I want to rewrite this so I don't have a denominator, I'd have to multiply both sides by that x2 minus x1. So this would move it over here by the slope. I need to put it in parentheses because I have to do the slope times that whole group. Now, this slope formula looks a lot like the point-slope form here. The difference, though, is that we don't see these 2's in that point-slope form. The reason why we don't see those 2's is we're only plugging one point in, and we know the slope. When we use the slope formula, we don't know the slope, so we have to know 2 points. So it's different information that we know with this. So the things that we're going to plug in is that we're going to plug in the slope into this form, and we're going to plug in 2 points. We're going to have our y from a given point, and then we'll have the x from a given point. So let's look at this example of how to do that, and then we'll talk about reasons why we might want to do this. So down here, using this point-slope, find the slope-intercept equation of the line through 7, -4, and with a slope of -2. So my points, I have my point and I have my slope. So I can go right to this form. So y minus my y value. So -4 is what I'm going to plug in, so that makes this a +4, equals my slope of -2. And in parentheses, I'll have x minus my x value of my point, which is 7. This right here is an equation. Now, the problem asked me to put it in slope-intercept form. Okay. So I'm just going to keep on getting rid of my parentheses and getting y by itself. I don't have to replug anything else back in. So I'm going to distribute first. So I get a -2x plus 14. And then from there I can subtract 4 from both sides. So I have y equals a -2x plus 10. I didn't have to find a y-intercept and replug it back in. I was just really simplifying and changing the form once I plugged in that point slope. So reasons why we might do this, okay, it could be quicker. So we saved some steps throughout that. Another one is we might minimize errors. We have no need to go back, plug in numbers to a final equation, so it can eliminate some of that back and forth. And the last reason really is that we do use it a lot in upper level math. It can be much faster because in some cases we can leave it in that form. We wouldn't have to put it in slope-intercept form. When it looks like this is actually an equation of a line right away. Okay. But if I was to use slope-intercept form and put this in, so like if I had -4 equals -2 times 7 plus b, that is not an equation of a line. That helps us to be able to find the y-intercept, but in that form, it's not an equational line. We don't see the x and the y in there that would be representative of an equation of a line. So especially in calculus, you do use the point-slope form a lot. So I challenge you, if you know you're going to be entering into calculus eventually, to use this form more so that it's familiar to you. as we see that this form isn't something radically different, it's really derived from our slope formula. And we're just moving that denominator over to the other side of the equation.